Alright guys, today's August 4th and we're going to be taking a look at complex numbers. Okay, so what are complex numbers? Well, whenever you have a number of the form a plus bi, right, where this is a real number, right, and this is a real number, right, and then I is an imaginary number, you have a complex number, right? So you'll notice there's a real component, which is the a, and then there's an imaginary component, which is the bi. B will be a real number, but when you multiply it by I, it becomes imaginary. So complex numbers have both a real component and an imaginary component. Okay? Now we're going to take a look at operations with these, and in order to help us with operations, what we're going to do is we're going to treat the values as terms, right? So we can combine like terms. All right. So that means we're going to treat I almost like X, right? And then we can just combine those terms pretty easily, right? So let's take a look at our operations. First operation we're going to take a look at today is addition. This is very straightforward, okay? Generally speaking, if you have a plus bi, complex number, and you add it to c plus di, complex number, what you're going to get here, right, is we take a look, a and c are both the real components, so I'll do a plus c, and then here, bi and di are both the imaginary components, so I'll have plus bi plus di, right, and then I'll just simply add my plus sign in between them, so I'll end up with my real, bless me, my imaginary component, okay? So let's take a look at some examples. We'll do these pretty quick. All right. We have 3 plus 4i. I'm going to add that to 2 minus 6i. I'm just going to combine the ones that go together, right? So here 3 and 2 are like terms. 3 plus 2 is 5. 4i and negative 6i are like terms. So 4i plus negative 6i is negative 2i. So I get 5 minus 2i. All right. We can go ahead and take a look at another example, number 2. We can have 5 plus 2i, and to that we can add negative 3 minus 5i, right? Again, if we go ahead and combine this here, we've got 5 plus negative 3, which is 2. Then we have 2i plus negative 5i, which is negative 3i. Okay, very straightforward. And then we're going to go and take a look at one more. Number 3. We've got 6 plus I root 3 plus 4 plus 5I root 3. Alright, again, same thing. 6 plus 4 is 10. And then here, if you have an I root 3 and I have 5I root 3's, we add them together, we will have 6 I root 3's. Okay, so that'll be our answer. So that's addition, very easy. Now on the other side of that, we can go ahead and take a look at subtraction, which works very much the same. When you take a look at subtraction, you really have one of two options. You can subtract both components of the second number, or you can go ahead and distribute the negative 1 ninja. So we're going to go ahead here and just put subtract both, right, or negative 1 ninja. I know how to spell ninja. Oh god, that's embarrassing. All right. So here, we'll dive right into some examples, right? So we have here 2 plus 3i minus 5 plus 4i. Now here I'll just show you the subtraction, right? So I always go to my operator. So it's going to be 2 minus 5. Well, 2 minus 5 is negative 3. And then here I've got 3i minus 4i, which is minus 1i. So we get negative 3 minus I. Alright, so that's just making sure you subtract both. So 2 minus 5, 3i minus 4i. Okay. We can also do a method where we distribute what we call the negative 1 ninja. So if we have here 5 minus 2i, and from that I'm going to go ahead and subtract 3 minus 9i, right? I'm going to go ahead and change this from being a subtraction sign in the middle to being plus a negative 1. So there's my negative 1 ninja that was hiding out front. And then I simply distribute my negative 1 inside. Now it becomes an addition problem. So now I have 5 minus 2i plus, then when I distribute that, negative 1 times 3 is negative 3. Negative 1 times negative 9i is plus 9i. And now it's just like the addition problems we did previously. 5 plus negative 3 equals 2. And then negative 2i plus 9i equals positive 7i. Okay? So again, just another way to do it. You can really do whichever one you're most comfortable with. All right. Another thing that comes into play here that we don't want to forget is just in general, radical terms behave the same way. So it's worth talking about them right now, even though they're not complex numbers. So if you're negative 10 plus root 2 minus 5 plus 3 root 2, you can see there is no imaginary component, so it's not a complex number, and that's fine, right? But what we're going to do is we're still just going to combine the like terms, same way, right? So negative 10 minus 5 is negative 15, right? And then root 2 minus 3 root 2 is negative 2 root 2, right? And again, I could have done the negative 1 ninja. Both would have got me to the same conclusion. Right? We can see how it's similar, which is why it's worth talking about. All right? I'm going to go ahead and move on to our next operation, which is multiplication. Okay? So here, our third and final operation today is going to be multiplication. Now, you'll find that this one's actually fairly challenging, right? There's a lot of different ways to look at it. Since we started our conversation about radicals, let's go ahead and keep that conversation going, right? So radicals, how do I multiply them? Well, we probably know square root of 3 times the square root of 2 equals the square root of 6. Easy peasy, right? No problem there. Likewise, if we have one that's a little bit more complex, like 4 root 2 times 3 root 5, right? We know we're going to multiply the numbers on the outside. 4 times 3 is 12. And we're going to multiply the numbers on the inside. Root 2 times root 5 is root 10. Okay. Now, the one thing we do have to remember is if we come across something like root 3 times root 15. Okay. Now, you can either go ahead and multiply them and then simplify, or you can start to break them down and see what happens, right? So here, if I rewrite this as root 3, and then I break this one up as root 3 times root 5, I end up with 3 root 5, right? And that's the answer here, right? It's 3 root 5. So that's just a way to break it down. Had I done it the more traditional route, I would have done 3 times 15 is root 45. But then I would have broke the 45 down and said, hey, let's go ahead and work that root 45 and break it down to root 9 times root 5. And the square root of 9 is 3, so I get 3 root 5. You can see regardless of which way you do it, you're going to get the same answer. That's one of the reasons these are so tough to talk about is there's so many different ways to do it. Okay, so that's how radicals behave. It's very important you always reduce, right? I want you to always reduce radicals. Okay, so always reduce radicals. Now we know how radicals behave. We should probably talk about how imaginary numbers behave, right? So the imaginary unit, right? We've been talking around this, but we have this imaginary unit which is just I, right? And we know what I equals. I equals the square root of negative 1, okay? So that's I. Now some interesting things happen here though, right? If we go ahead and square I, we have the square root of negative 1 times the square root of negative 1, which is just negative 1, okay? The square roots cancel with the squared, right? Now I cubed is equal to negative I, right? And we think about why that happens. You kind of break down I cubed. Say, well, I cubed is equal to I squared times I. And we just saw that I squared is negative 1, so it becomes negative 1 times I. And we know that negative 1 times I is just negative I, right? So that's why I cubed is equal to negative I, okay? And then finally, we have I to the fourth, which is equal to positive 1, right? And for the same logic, right, if we break I to the fourth down to I squared times I squared, that's negative 1 times negative 1, which is positive 1, okay? So these are the different powers of I. Any other power of I just basically reduces to one of these four possibilities. We're going to end up with I, negative 1, negative I, or positive 1, okay? For example here, right, if we were to take a look at, say, I to the fifth, well, I can just start taking out I to the fourths, right? And that'll equal I to the fourth times I. We know that I to the fourth is just 1, so it's just I, right? So these cycle back. These are really the only four possibilities with I, right? Again, just so you know, we do I to the 11th, right? That's going to equal I to the fourth times I to the fourth times I cubed, right? 4 plus 4 plus 3 is 11. Now I to the fourth is 1. And then I cubed we know is negative I. So I'm with 1 times negative I, which is negative I, right? So again, you'll see it'll always cycle, excuse me, it will always cycle back to be one of these four possibilities, okay? Always. So that's how the imaginary unit behaves. Right? Now that we've done that, we can kind of dive in here to actually what is multiplication. So multiplication, and we'll take a look at an example, and we'll just do it in both ways, right? So here we've got 3 plus 2i, and we're going to multiply that times 5 plus 3i, right? Now, there's a couple different ways to do this. I'm a big fan of the second method I'm going to show you, right? So the first one we're going to look at is what's called the FOIL method, right? And FOIL stands for first, outer, inner, last. Some people do it with like this whole smiley face thing. I don't really know. What I do here, right? 3 plus 2i plus 5 plus 3i is I just underline them, right? So here for the first, I'm going to underline the first number in each term. So 3 times 5 is 15, right? For the outers, I'm going to do the two extremes, right? So the furthest one to the left and the furthest one to the right. So I've got 3 times 3i, which is plus 9i, right? Then I can go ahead here and do the innermost two, right? So it'll be 2i and 5, the two in the middle, right? So 2i times 5 is plus 10i, right? And then finally, I'll have to do the last terms, right? I'm running out of color, so I'm just going to switch back to black here. So I got 2i times 3i. 2i times 3i is plus 6i squared, okay? Now here you can see they've all been underlined twice, so I know I've hit them all, right? So I did my first, my outers, my inners, and my last. Now I'm just going to combine like terms. Now, two of these are easy to see, right? 9i and 10i are like terms, and I get 19i, right? What a lot of students miss here is 6i squared and 15 are like terms, right? Remember we just talked about I squared is negative 1. So what I like to do is I like to cross out the I squared, and when I do that, I change the sign. So now I have 15 plus negative 6, which is 9, okay? So that's going to be my answer is 9 plus 19i. Right. That's the FOIL method. I'm a bigger fan of the box method. It takes up a little bit more room, but I find students are less likely to make mistakes. So here we'll do the same exact example, but this time we'll box it up. So we've got here 3 plus 2i, and we're going to go ahead and multiply that. Oh my goodness, I put addition here. It should be a multiplication symbol. That's embarrassing. All right, times 5 plus 3i, right? So to box these up, what I do here, right, is essentially draw a 2 by 2 box underneath one of the terms. That doesn't really matter, right? I picked under 5 plus 3i. What that means is I'm going to have to rewrite 3 plus 2i vertically. So I'm going to bring the 3 right here, right? I'm going to bring the 2i down here. Right? And it's a positive 2i because that's a plus, right? Now I multiply to fill the boxes, right? Very straightforward. So here, 3 times 5 is 15, right? 3 times 3i is 9i. And now I multiply 2i times 5, 10i. And then 2i times 3i, which is 6i squared, okay? And if you do this right, the diagonals should be your like terms, right? So we've got 10i and 9i Together that's 19i, right? And then here, I squared, I cross out and change the sign. So I have 15 plus negative 6, which is 9. So you can see I get the exact same answer I had before. All right. So again, those are the two methods for multiplication. And if you can do those, the other ones become much, much easier. All right. So if you have any questions, go ahead and email me. We're going to do some additional examples in class where I'll let you try some on your own, and then we'll have a homework assignment.